By initially determining the values that will make the fraction undefined and making that a different step, we can avoid what most textbooks require you to do, which is to subtract a 1 from both sides and then turn around and get a common denominator to add the 1 to the 5 over x plus 4. We can avoid having to deal with a common denominator by just starting out saying x plus 4 is equal to 0 when x is negative 4. That takes care of that part. And we can now change this to an equation. 5 over x plus 4 equals 1. By making an equation, we can go ahead and multiply both sides by the common denominator. So I can multiply both sides of this by x plus 4. Over here is just going to cancel. So I've got 5 equals 1 times x plus 4 is x plus 4. Subtract 4 from both sides gives me 1 equals x. So the two critical points, the two critical values are the negative 4, which makes it undefined, and the 1, which makes it equal to 1. Notice if I come back here and plug in the 1, I get 5 over 5, which is where it's equal to 1. So what I want to do now is find my intervals. So I'm going to graph my negative 4 and my 1. Now, this has the equal to part, and it's okay for x to equal 1. So this can be a bracket. However, even though this has the equals, I can never use negative 4 in this problem because it's going to make it undefined. So this has to be a parenthesis. So my intervals are going to be from negative infinity to negative 4, with a parenthesis on the negative 4, parenthesis negative 4 to 1 with a bracket, and 1 with a bracket to infinity. As usual, my test value can be anything in this interval. So I can use negative 5 for here. I can use 0 for here. I always use 0 unless it's actually one of the endpoints because it's so easy to plug in. And then 2 would work for here. So if I plug in negative 5, I'm going to get 5 over negative 5 plus 4 is greater than or equal to 1. If I plug in the 0, I get 5 over 0 plus 4 is greater than or equal to 1. When I plug in the 2, I'm going to get 5 over 2 plus 4 is greater than or equal to 1. Now, in this case, this is going to be 5 over negative 1, which is a negative 5, which is not greater than 1, so that's false. This is going to be 5 over 4. 5 over 4 is 5 1/4. That is greater than 1. This is true. This is going to be 5 over 6. 5/6 is not greater than or equal to 1, so that one's false. So my solution, it was true in the middle, so my solution is from parentheses negative 4 to 1 bracket. And of course, if they want it to be graphed, it would be from negative 4 with a parenthesis to 1 with a bracket, and color it in between. Let's look at one more problem. How about something like 4 over x plus 1 is less than or equal to 2 over x plus 3? Now notice that we have two denominators that are different. So we've got to set both denominators equal to 0 and find our critical points there. So x plus 1 is 0 when x is negative 1. X plus 3 is 0 when x is negative 3. So these will be where it's undefined. So it's undefined at x equals negative 1. Oh, that's a negative, sorry. And negative 3. Now make it an equation. 4 over x plus 1 is equal to 2 over x minus 3. Common denominator, our least common denominator, is going to be x plus 1 times x plus 3. So I want to multiply both of these by x plus 1 and x plus 3. So times 4 over x plus 1 equals x plus 1 times x plus 3 times 2 over x plus 3. This is annoying, but it's still a lot better than having to get a common denominator and add these, I promise. Clear out the x plus 1s. So I've got 4 times x plus 3 equal to the x plus 3's cancel. So I've got 2 times x plus 1, 4x plus 12 equals 2x plus 2, linear equation. Subtract 2x from both sides. Subtract 12 from both sides. Cancels. 2x equals cancels negative 10. X equals negative 5. It's equal at x equals negative 5. Everybody's negative. So the critical points, got to put them in order here. So negative 5 will come first, and then negative 3, and then negative 1. My intervals, this is negative infinity, positive infinity. So I've got from negative infinity to negative 5. This has the equals, so I can include the negative 5. I can include this one. I can make that brackets, but I cannot include the negative 3 because it makes it undefined. Same for the negative 1. I cannot include that no matter what. So negative infinity to negative 5, negative 5 to negative 3, negative 3 to negative 1, negative 1 to infinity. Those are my intervals. My test values could be a negative 6, negative 4, negative 2, 0. So when I put in the negative 6, I get 4 over negative 6 plus 1 is less than or equal to 2 over negative 6 plus 3. This is going to give me 4 over negative 5 is less than or equal to 2 over negative 3. This is a negative 0.8 is less than or equal to negative 0.65 7, just go far enough to see which one is actually smaller. Negative 0.8 is farther to the left than negative 0.6, so this is true. Let's try the negative 4. 4 over negative 4 plus 1 is less than or equal to 2 over negative 4 plus 3. This is going to be 4 over negative 3 is less than or equal to 2 over negative 1. So negative 4/3 is less than or equal to negative 2. Not true. Negative 2 is farther to the left than negative 1 1/3. So this one is false. So I'm pretty sure it's going to switch back and forth, but let's double check. Negative 2. 4 over negative 2 plus 1 is less than or equal to 2 over negative 2 plus 3. This is going to be 4 over negative 1, which is a negative 4. It's less than or equal to 2 over 1, which is 2. Definitely true. And plugging in 0 should be easy. 4 over 1 is 4. 2 over 3. 4 is definitely not smaller than 2/3, so false. So the solutions are negative 8 to negative 5, with a bracket on the negative 5, union from negative 3 to negative 1, both of which will be parentheses.